I mentioned that a lot of this passing a checking account to something that's expecting a bank account has to be with pointers. The reason is because when you copy solid objects around, you get something known as slicing. If I take a checking account that has a balance and who owns it and all that contact information, as well as an overdraft limit, and I copy it into a bank account object that doesn't have a place to keep overdraft limit, the absolutely best thing that can happen is that the overdraft limit will just get thrown away because there's no place to put it. I mean, the worst thing that will happen is some kind of runtime error. So you can take a checking account pointer and give it to something expecting a bank account pointer, that's fine. But if you take an entire solid checking account and give it to something that's expecting a bank account, you're going to lose some of the checking account information. That's not necessarily an error, but it is if you then want to try to somehow get some virtual behavior where you'll see the use of the derived class's member variables. There is no derived class anymore, and those member variables are gone. Similarly, you can't take a bank account and copy it into a checking account because there's information missing from that base class that's needed in the derived class. We do simple demos where we declare things and set them equal to things, but as I've said many times before, what really happens in live C++ programs is that things are being copied back and forth to functions because functions are what your app is built of. If your function takes things by value and the types are different, either the copying will entirely fail or slicing will happen, depending on which direction you're going in. Slicing's bad because you're throwing information away, and certainly copies failing is also bad. And that's why it's so common not to pass by value, but to pass by reference or to use pointers. References use the same syntax as solid objects. Use the dot instead of the arrow. Some people find them a little easier to read. Polymorphically, there's no real difference between references and pointers. The same rules apply about, oh, I'm expecting a bank account reference. Sure, here, have a checking account reference. And that's why people use references and pointers when they're passing things around to functions.